Evidence for the Younger Dryas cooling event is found all over the world. This slide shows data from the Gisp ice cores in Greenland, sediments from the Cariaco Basin off of Venezuela, ice cores from Antarctica, and marine sediments in the North Atlantic. All records show evidence of cooling between 12.9 and 11.5 thousand years ago. So what caused this cooling, and could it happen today? As early as the 1980s, scientists expected the cause of the Younger Dryas was related to the North Atlantic. Evidence reported by Ruddiman and McIntyre in 1981 showed that sea ice extended far south of its present position prior to 15,000 years ago, but shrunk northwards between 15 and 13,000 years ago, then extended far south during the Younger Dryas. Do you have any ideas what this cooling could be related to? Think back to when we learned about oceanic circulation and the thermohaline circulation. Scientists believe that the melting of the massive ice sheets resulted in freshening of the North Atlantic. This would decrease density difference and shut down thermohaline circulation, resulting in a loss of heat transfers around the world. This slide and the next illustrate this and some of the climate consequences. Some of the consequences of a shutdown of thermohaline circulation include that temperate climates in North America becoming colder, drier, and windier. Monsoonal areas in Africa become drier. Could warming temperatures today cause thermohaline circulation to shut down or slow down, similar to what occurred in the Younger Dryas? The futuristic film The Day After Tomorrow suggests yes. The IPCC suggests it is unlikely in the next 100 years, but suggests using models that thermohaline circulation could slow down by 25% by 2100. This is illustrated in the image below. However, research published in 2005 based on ocean measurements showed a decrease of 30% in thermohaline circulation flow from 1950 to the present. Although research suggests that a complete shutdown is unlikely, scientists have put in place a monitoring system comprised of 3 arrays that cross the Atlantic Ocean. This is to monitor and keep track of thermohaline circulation in the North Atlantic. If thermohaline circulation were to slow down or even completely shut down, the impacts are many, as indicated on this slide. As well as changing climate worldwide, what other consequences did we learn or did we find out about by studying the Younger Dryas? One of the most significant is megafauna extinctions. Megafauna extinctions occurred about 13,000 years ago. At this time, there were many large mammals, including the saber-toothed tiger, the giant sloths shown in the lower panel, the giant beaver, and of course mammoths. Approximately coeval with the Younger Dryas, about 33 of 45 large mammal genera went extinct. Could this have been due to climate change? Several hypotheses have been put forth, including overhunting, climate change, disease, and meteorite impacts, to explain the loss of megafauna at this time. The overhunting hypothesis was first proposed by Dr. Paul Martin. At the time, evidence indicated that humans first arrived in North America about 13,000 years ago, coincident with the megafauna extinction. Dr. Martin found several sites where mammoth bones were found, along with Clovis tips. Clovis tips were used in spears associated with the earliest people to arrive in North America. You can see an image of a Clovis tip on this slide. Many studies since have shown that overhunting on its own probably wasn't the only cause of megafauna extinctions. The most likely other candidate is climate change. Climate change could have affected megafauna in several ways. First, highly variable climate during the Younger Dryas may have been too much for megafauna to adapt to. Climate change could have occurred so fast that megafauna could not flee to new locations that had the required habitat. And three, changes in the type or coverage of vegetation may have caused food shortages for many megafauna. Scientists have used models to test these various hypotheses. Although the cause of megafauna extinctions continues to be hotly debated, modeling suggests that a combination of climate change and overhunting were the most likely causes of megafauna extinctions. Today, extinction rates are also high, with multiple factors putting many species at risk. What are some of the stressors today causing high extinction rates? This plot uses a conservative estimate of a background extinction rate of 2 species per 10,000 species per 100 years. The plot shows how long it would usually take for the number of species that went extinct in the last approximately 100 years to go extinct. Results show that it would have taken 800 to 10,000 years depending on the animal group. This data and other data show extinctions are occurring rapidly. What is causing rapid extinction rate today? Habitat loss, overexploitation for economic gain, pollution, and now climate change. What does the Younger Dryas and megafauna extinctions tell us about the future for species on Earth? Data from the past suggests that climate surprises are possible. Although we still don't understand what caused the rapid increase in carbon dioxide in the atmosphere during the PETM, scientists worry that there may be feedbacks we don't yet understand associated with oceans that could trigger a rapid increase in carbon dioxide to the atmosphere in the future. From studying the Younger Dryas, scientists continue to be concerned about the possibility of a slowdown in thermohaline circulation and are carefully monitoring the North Atlantic. This map shows many other potential abrupt climate changes that could occur in the future and that scientists are working very hard to better understand. Wally Broecker was a very famous paleoclimatologist who worked on all sorts of problems and questions about climate change. But probably his most significant work was looking at the Younger Dryas and looking at modern climate change. So I end this section with a last word from Wally Broecker, who said, "Climate is like an angry beast that we are poking with sticks."